Yesterday we were at log 15a, and let's continue on that. We did a number 15. So we chose some, questions. Today, how about we start with number 6? What do you guys have any questions? Do you have any specific questions? Yes, no? Good morning. Andy, Mikhail? Andy and Mikhail. Okay, so how about we start with number 16. Okay, we have seen a variety of situations, right? But not all of the situation yet. So in some situation we have, we check the solutions, and we did number 15. So the numbers are typically our solutions after checking, right? And we have done a problem that one of the numbers is not in the domain, therefore it's not a solution. So number 15, what we worked with yesterday, it is, we have two solutions, and we have two solutions. Both are solutions after verifying. But anyway, so with that said and done, okay, and today we're going to start with number 16. Okay, we'll see this, what happens here. And then maybe we're heading for 18. So let's look at 16 and 18. Okay, 16 and 18. Let me turn on the light. Okay, number 16. So we have log base 9. Okay, of x minus 5 plus log base 9 of x plus 3 equals to 1. Okay, and of course we're going to start with domain. Well, to consider domain, we have two quantities we need to guarantee that there must be in the, must satisfy omega greater than 0. One is x minus 5, must be larger than 0, and the other one, and if they're connected by and, x plus 3 must be greater than 0. So we get the x is larger than 5 and x is larger than -3. Okay, so I want to put a note here. When you set up, okay, in situations like this, when you set up situation like this, okay, this step, okay, I will be looking at this greater than 0 and this is greater than 0. 3 parts, 1, 2, 3. So this setup is worth 3 points. Okay, and the final, of course, the final domain you found is going to worth 2 points. Okay, it's going to worth 2 points. So what will be the final domain here? Okay, so you will look at the number line, right? Use the number line as our aid. Larger than there's a -3, right? And there's a 5. Larger than -3, let me use some, notation here. It should be a circle here, right? It should be a circle here. Larger than 5 are these numbers, okay? And keep going, not including 5. Larger than -3 would be including all of these points. And keep going, right? Keep going. So the part that's been marked twice, which is a condition is satisfied, right? And so the final answer for the domain would be, what would that be? X larger than 5, right? Okay. All right. And then we're going to solve this equation. We're going to solve this equation. To solve this equation, of course, we're going to use a product rule, right? Product rule. And the product rule, we will get the multiplication of these two, right? X minus 5. Right, so this piece, we use this product rule. And then the next step, we're going to use definition. So x minus 5 times x plus 3 is equals to 9 to the power of 1. It's just 9. It's 9. You don't have to write 9 to the power of 1. Okay, either way. 9 to the power of 1 is equals to 9. So we're going to solve this equation. Okay, so let me clean this up a little bit. Do we know how to solve this equation? Do we know how to solve this equation? Yeah? Right? Do we know how to solve this equation? It's a quadratic, right? It's a quadratic equation. You can solve it by any way you wish to, but you will have to make it x squared, okay? Minus 2x minus 15 minus 9 equals to 0. Make 0. Make 0. Right? Make 0. Yeah? And then what? Negative 15 minus 9 is negative 24. And factor, right? So this uses definition. Okay. These steps will be the, where points are given. Okay. I would say probably 2 points each. Okay. And of course, I will check things in between. I'll check in things in between. Factor. We get x plus 4 times x minus 6 is equal to 0. Am I right? Do we get the same factors? If you don't factor, use a quadratic formula will do too. Okay, and then we get product rule. I'm sorry, not product rule. Principle number 5, right? Principle number 5, x plus 5 is equal to 0, or x minus 6 is equal to 0. So x equals to -4, or x equals to 6. Okay, and then domain check. What is the domain? X is larger than 5, right? Domain is x larger than 5, right? So x, so you can say -4 is outside of the domain, right? So obviously x equals 6 is inside the domain. So for x equals to 1, x equals to 6, right? You can say 4 x equals to 6. And when we check a solution, we always go back to the original. Okay, so we have it here. Okay, and you start from left-hand side. Yesterday, I have spent some time explaining to you why you must do it this way. Okay, because it is logically sound. X is 6. So 6 is in place, right? Log base 9 of 1, that's 0, plus 1, that equals to 1. That equals to right-hand side. So when you read it, right, when we read it from left to right, top to bottom, you say, then we will see the context. When x equals to 6, the left-hand side of the equation is equals to 1, and it is the same as the right-hand side. Therefore, when x equals to 6, it makes the statement completely true, right? It makes the if statement completely true. So you can also say these, right? You can say x equals 6 is a solution, if you want to just make it shorter, right? To the equation because, right? So this is the because, and we're done. So you can see that in this situation, right? Unlike in question number 15, we found 2 numbers, both are solutions. But in number 16, you found 2 numbers, but one is a solution, one is not. And then you'll be asking, are there situations that there's no solution? Yes. Yes. Okay, let's look at number 18. Okay, let's look at number 18. Any questions so far? Any questions? Oh, I haven't talked to you about the points, right? You use product rule or quotient rule. You use it correctly, that's 2 points. You use the definition correctly, or however you get to this place, you get 2 points. A typical mistake, guess what it is? A typical mistake is, someone put a 1 here. Did you see what's wrong? That the definition was not used properly. Okay, so this place should be a 9 to the power 1, right? And then you go down the steps and then you find 2 solutions, right? You find 2 solutions. So factoring probably will give you, in this place, factoring probably just give you 1 point. Okay, by the time you find these two solutions, each number should worth 1 point. So 2 points total. Okay, domain check is worth some points. Okay, domain check is 2 points. We found domain, so we use it. Domain check. Okay, and this check, okay, this piece of check, each piece, sometimes you have two numbers, right? You need to check both. Okay, and that's a 2 points. Okay, I'm addressing these issues because you are going to have a written quiz today. You're going to have a written quiz today, and you're also going to have another quiz. Okay, but one of them is a quiz. It's written. Okay. All right. All right. Is that clear, everybody? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 16 points. Okay, total of 16 points. Okay, so from the beginning, domain setup, determine the domain, right? Combine these two, determine the domain, right? You can put this over here. It doesn't matter where you put it actually, but this seems to be a more reasonable order. Okay, and then you solve it, go through the steps, show nice work, show nice work. This is showing nice work is something I recommend for you to do all the time, always show nice work. Okay, as long as you stay before you get your degree, anything you do in school, for school, you just try to do the best you can. Okay, make it nice work. And typically you probably need to write it down, once or three times. Maybe one time it doesn't work very well, just clean it up and do it again. Okay. Because every teacher likes to see a piece of nice work. A nice work not only makes it much easier to grade, it also shows your attitude. Okay, it shows your attitude, and your attitude is actually, your attitude affects affects your graders in many ways. Of course, we do it fairly, right? Because sometimes we cannot find something on your paper, then we cannot give you that points. We cannot give you those points. Okay. And throughout the semester, what I've been trying to do in class, and I try to show you the work I want to see. Okay. Then you say, how do I show your work? Every single day I'm teaching, the work I show you is the work I wish I see from you. Is that clear? I'm not say, oh, I want to see this kind of work, but I don't show you this kind of work. No, that's not me. I do, I hope I have done, I treat the way I wish to be treated. Okay, I have that something on my bookshelf. It tells me, do to others as you would have done them do for you. That's my motto. Okay, did I read it right? Because we always change the way we say it. Okay, I try to treat others the way I wish to be treated. Okay, and so is that done in my teaching. I show you the work that I wish to see from other people. Okay, and this is also the reason why I insist on typing it, typing instead of handwriting. But sometimes, I have to write it by the mouse, and because of the limitation of the software or the limitation of my ability of using the mouse, right? That's out of, I don't have many other choices. Okay, I do have some handwriting tools, but I'm not satisfied with them, and I'm not satisfied with my handwriting, writing on those tools. Maybe after I practice and do better on this, I will start using it. But I find typing is more to my satisfaction. Okay, I certainly don't expect you to write your work as if you're, the same typing, but it should be as clear. It should be just as clear. Okay, and I also encourage you that you do this. Really, it will benefit you ultimately. Okay, when you show a nice piece of work, for some reason, I think it's much easier to find the points to give it to you, and so in the end, you are the beneficiary. All right, so I hope that I have made myself clear, right? Do to others as you would have them do to you. All right, that's from Luke, right? That's from Luke, and we got that. But anyway, let's look at number 18. Okay, number 18. I choose some questions, so we're not doing one by one, but we choose some questions so that we touch with a variety of issues. Okay, variety of issues in terms of, for this kind of if statement, right? How many solutions do we expect? Sometimes there's no solution. Sometimes there's one solution. Sometimes there are two solutions. And sometimes there might be one is, the one solution, the other one is not adequate because it's out of domain. So there are all kinds of situation, or sometimes there's no solution at all. So that's why we have to check. That's why we have to check. Okay, so let's look at this one. This one, we have absolute value. And this is a +3. The right-hand side is equals to 1. So this if statement is we want log base 2 of, whatever in the parentheses, and we want that to be equals to 1, to be exactly 1. Now, first let's look at domain. Okay, the omega in this situation is really the whole thing in the parentheses. We want this to be larger than 0, right? We want this to be larger than 0. So what do we get for x? What do we get for x? What do we get for x?
Would it be x is less than -3 or x is greater than 3?
Can you write it down? So you can write down on chat. Think about the meaning though, right? Think about what it means. Think about the meaning. Think again. X is less than -3 or X is greater than 3. So what you meant, right? And Andy's work is this. So choice B. So when you choose this answer, right? You're telling the reader that if X is less than -3, and that would be true. If X is larger than 3, and that would be true, right? And so you meant that between so your implication is -3 doesn't make it true. +3 doesn't make it true. Any number between -3 and +3 does not make it true. Is that what you meant? But is that true?
That's what I meant, but it's not correct.
Right? When you check the answer, then you realize that's not true. B. Right? You subtracted 3 on both sides, but the B is incomplete. We want to eventually isolate X. So X is not isolated. So it's not done yet. So this is a questionable, right? Obviously you have left out some solutions, didn't you? Because if I put 0 in place, it will still be true. 0 is not in your described interval, right? And this one, incomplete, you're gonna have to solve that inequality. Do we have another choice? Yeah. Okay. Remember we learned that the absolute value of X is always greater than or equal to 0. If the absolute value of X is always greater than or equal to 0, and that quantity plus 3 is larger than 0, isn't that true for any real number? So what is a domain then? The domain is all real numbers. Okay. All right. Remember that powerful statement we have learned before. The absolute value of X is greater than or equal to 0. Okay, when we were doing basic 1, right? When we were studying this function, the absolute value of X is greater than 0 for any real number X. Did we really understand that meaning? If we do, this is the time to apply it. Because this quantity tells you this, that you're not going to get anything less than 0 here. You always get a positive or 0. A positive or 0 number plus 3, that's always a positive. It's always greater than 0. So this, and that is true for any real number. Therefore, the domain is all real numbers. But why did we fall into here? Right? In my view, that when you solve inequality, right? In my observation, a lot of our students, when they solve this inequality, okay? When they solve this inequality and they get to the next step. Is that right, Bailey? But if you think again, we have solved this kind of inequality before, didn't we? If the absolute value of x is always greater than or equal to 0, so this is always true, isn't it? Well, how did we get here? We get into something we call autopilot. Do you agree with me? So you always have to think of the meaning and think of the domain and range, right? Because we have learned, this is a very common mistake. This is a very common mistake. This is a very common mistake. So the source of observation, correct me if I'm not right, okay, is that had you have the absolute value of x larger than positive 3, then you get there, right? Yes? If in another situation, if you solve for x and the absolute value of x is larger than 3, positive 3, then your answer will be right. And when you do what absolute value greater than negative 3, then you also get to the same thing. That would be completely wrong. Do you follow me? The perspective I wish to give you, this is very, very common mistake, is that you need to realize, okay, it is possible for absolute value of a number to be larger than 3. And it is always true the absolute value of any number is larger than negative 3. And I wish to give you another perspective, okay, because I see these mistakes happen too often, right? Remember the picture we have done? One of the things you do when you do mathematics, you don't want yourself to get on autopilot, which you should remember the steps, right? When you see this, you do that, you see, and then you do the next one. I tell you, if you have done that before, you will realize sometimes you're right, sometimes you're wrong. And what will make it, what will be saving you is that you have to think about it a little bit. You have to think about it. You have to think about the meaning. You have to think about the, the situation. For example, the absolute value of x, right? So I want to give you another perspective. Remember when we were doing basic 1, we did a picture for every one of them, right? We did a graph for every one of them, except 10 to the power x and a common log x. I admit we didn't do exactly every one, but we did almost every one of them, right? I did that for a reason. Okay, that was a lacking. Oh, okay, so we get another answer. Hold on. Thank you, Mikkel. So the other answer we get here, I will put it in the C over here. Okay, thank you, Mikkel. Okay, I will be addressing this answer as well. Okay. Right now, I'm addressing the difference between these two. Okay, the difference between these two. Now, if you have that picture in your mind, if we have that picture in our mind, right? So let me adjust the picture a little bit, right? So make it from -4, and this is say 5. And over here, make it a -4, +4, right? So I'm just making some adjustment to our pictures. What it means that for the absolute value of x is larger than 3. right? It's as if you have, you put a 3 here, okay, the black, use a green, okay, and broken line, medium. It's basically, you look at the crossing, right? You look at the crossing, the output larger than 3. Okay, think of this as a function. Okay. Remember, there's a Phantom movie. There's a song called "Think of Me," right? Now I'm going to change the lyrics. Think of function. Think of function, right? Think of function, function, function. How's my singing? Are you impressed? One day we should sing together, right? Somebody play the guitar for me, right? All right. Think of function. Think of function, right? So the input is X, and it goes through this machine. Oops. Okay, it goes through this machine, right? And this machine is going to give you absolute value. And it's going to come out as output. In this situation, what do we want? We want the output to be larger than 3. We want output larger than 3. Okay. Larger than 3, where do you find output larger than 3? Right? This crossing, you can find you can find the crossing very quickly, right? You can find the crossing very, very quickly. So this crossing basically, this green line is y equals to 3, right? So you output equals to 3. Okay, i.e. output is 3, right? And you want to be larger than 3. So where do you get those? Well, you're going to get those other output larger than 3. This is where you get them, right? These output are larger than 3, right? So anything higher than that, that's where you get the output. So then you realize, oh, your solution is going to be where? Because you're looking for input. We're looking for input. The input is going to be what? It's going to make the output larger than 3. So where do you find those input? Which is that's a description, less than -3, right? Larger than 3, right? Okay. Now, that's the situation for greater than 3. But what happens if it's greater than -3? Where do you find that? What is greater than -3? You want the output to be greater than -3. What is the geometric interpretation? That's a -3. Do you guys follow me? I want you to visualize this. This is y equals -3. You can see the entire curve is above this y equals to -3, always, no matter what the input. Do you follow me? Okay. So that's why when we do that autopilot thing, we got the right answer. We got the wrong answer, do we? So sometimes we get the right answer, sometimes we don't, because we need to have these visuals. You need to constantly think of function, function, function. Okay? You know that song, don't you? That's my favorite show. It's my favorite show. Okay? Now, you follow me? So let's look at the answer C. Let's look at the answer C. So in this case, okay, if you have this picture in your head, you probably wouldn't have made that mistake. Okay, so never ever allow yourself, to autopilot in math. Math is a game of thinking. It's all in the mind. Once you start that thinking, you can't stop it. It's something no one can take it away from you. But you have to be conscientious about it. Okay, I found these autopilot thing is very often. That's why we see these mistakes very often. Okay, so we have addressed these issues, right? So we have addressed A, we have addressed B. Now let's look at C. What's the meaning of C? The meaning of C says x is larger than -3 and x is smaller than 3. X is larger than -3 and x is less than 3. Okay, so let's see, what does that mean? Okay, -3, right? -3 and +3. I'm also showing you how to self-check your answer. Okay, this is the way how you self-check your answer. Okay, you're not going to allow yourself say, oh, I just put an answer there, let the teacher check it. No, you need to check it before you turn it in. Okay, you want to check it before you turn it in. Everything you put on paper, you check it before you turn it in. You have to think, does that make sense? Is that right? Okay. X is larger than -3. Okay, so we understand that all these is larger, right? So this is circle and this is circle, right? Larger than -3 means what? Larger than -3, that's larger than -3. Those are larger than -3. Do you follow me? And to eternity. And smaller than 3. Smaller than 3. What is smaller than 3? That's what you meant. That's what you tell the reader. You're telling the reader this, that only when x is larger than -3 and x is less than 3, when this is true. Oops, I'm sorry. Okay, let me do it again. Larger than -3, do you follow me? I want you to think logic. I want you to think truth table. Okay, I want you to think of logic. I want you to think of truth table. Okay, less than 3. Okay, and to eternity. Okay, so what we're saying, when this is true, when is this true? When this is true, then the absolute value of x is larger than -3. So you're basically telling reader the solution is only here. Okay, you're telling the reader the solution is only limited from -3 to +3. So what do you think of that? That means you have excluded 4, but when you plug in 4 in the in the inequality, it is still true. How do you explain that? Huh? How do you explain that? You have left out some solutions, haven't you? We have left out some solutions, right? Self-check, right? Self-check. So you know you should, well, this answer is equivalent. This answer is equivalent to -3 less than x less than 3. Okay, the same thing. Okay, this answer is the same as the other one. But they're both wrong. They're both wrong. Right? I can give you a counter example right away. Right? If I give you x equals to 4, it will be true. Right? And then you left out that solution. So can you see that you can self-check? And it's very easy to self-check. You get it, Mikhail? Right? So you have to think of incoherence, that the interpretation of our solution, it means that if the solution is in the, in your specification, and those are the solutions, and those are the only solutions. If you can think of a counterexample, and you must be thinking about those counterexamples, you constantly are thinking. I'm very sorry that doing math is training us to constantly thinking. Reflecting. That's why at the beginning of the semester, I was telling you the structure of sentences, right? The grammar. Right? A statement. Give you a statement, and these statements are just written, right? They tell you, sometimes it tells you the rule, sometimes it tells you the whatever. It gives us the context to think from, right? So for example, in the if statement case, you can if all the if you want, right? You can say, oh, if I get a lot, if I got the lotto, if I win the lotto, right? So if I win the super lotto, but that's not true. So some of the if leads something that's true. Sometimes the if doesn't lead anything true. Do you follow me? Sometimes the if leads some partial truths, the partial solutions. Do you follow me? So we can have all the if we want, but sometimes that the if doesn't lead us to any solution. For example, if I say if I win the super lotto, I'm gonna buy a house. I'm gonna buy a Tesla. So then you say, hey, by the way, are you dreaming? Right? So for me, it's very important for me to tell you the context, which is it's an if statement. It's an if statement. It's a big if. I keep writing that if statement in capital letter. Do you notice that? I want your attention. I want you to think in that context. It's a big if. So all of these equations we work with in equation setting, they're all big if. Okay, so is that the same situation when you get to computer science, when you start coding? When you learn coding, you will find that there are only two kinds of sentences in mathematics, in computer programming. One they call assignment. Assignment is a statement. And the other one is if. Okay, it's called a conditional statement. If is a conditional statement, we all understand, right? In computer programming, you only have these two kinds of sentences. So that's why we say computer science is based on mathematics. In the early days of computer science in the last century, in the 1940s, every person involved in computer science, that they were PhD in mathematics. Okay, they were great mathematicians. So everything mathematics is written in computer science. All the ideas, object-oriented, or even today's AI, data analysis, they all have something to do with mathematics. The foundation is mathematics, the binary code and everything, they're all mathematical. So it's important for you to see that perspective. That's what I'm trying to to show you, right? You think of function. This entire semester, we're talking about different aspects of functions. That's all you do. By the time you get to calculus class, you start with function. You start with function, okay? This is what I promise is that I want to keep things simple. So in the end, you see that, oh, it's just different rules. It's about input output, right? It's about domain range. Just the rules are different. Okay, I hope I keep saying these over and over again because I keep want to bring you back to the basic concept, So think of function, okay? Think of function. But anyway, I hope that's a helpful discussion. Okay? So now we're not done yet, right? We're not done yet. So let's come back. If the domain is all real numbers, right? So I'm gonna, I hope you guys write this down, okay? This is a discussion about solving that inequality. Okay, that's a discussion about solving that inequality, okay? And it's related, and how it is connected to what we've done before. Solving inequalities involve absolute value, okay? So I hope this is helpful because we've done these similar things before. And how do you make connections with these, right? Those basic things. Okay, so now I want to go further, right? So domain is all real numbers. Let's solve this equation. So what will be the next step? Definition, right? Definition. So that should be equals to 2 to the power 1, right? 2 to the power 1 is just 2, right? 2 to the power 1 is just 2. And what does x absolute value of x equal to? So if this is true, remember, when you read this sentence, in your mind, in my mind, this is if, then. Okay, and from here, if, then. Okay, every if statement, if then, if then, if then, if then. I agree it is boring. But don't we even have that repetitive melodies even in music? Isn't that in the rhythm of shooting loops, playing basketball, there's that rhythm, there's a repetitiveness? It's that repetitiveness, it's that repeated, shooting the loops, that's how some people become a star. Yeah? Right? But there's a pattern. There's its own beauty and a consistency. Okay, you can say it's boring. You can say it's a consistency, right? Which is a more positive comment. Two kinds of sentences in mathematics. There really are. No more. Okay. All right. So what's next? The absolute value of x equals to -1. Now you tell me what is the solution.
There is no solution.
Perfect. You got it. You got it. Because of what? Because of this powerful statement, right? Yes? I love it. I love it. You got it. Okay. So what do we say? No solution. If you need a because, then this is because. Isn't that statement powerful? Isn't that picture useful? That statement is consistent with the picture, isn't it? So that's why we say a picture tells 1,000 words. A picture tells 1,000 words. Sometimes it's how many words? 10 words repeated over and over again. Okay. But anyway, without further ado, I think we should take a break. Okay. Come back in 9:08. And I wish to tell you how much I really enjoy this class. Okay. And I hope you do too. But if you have any questions, and I'm here to help. Let's take a break and come back at 9:08. Welcome back. Are you guys back? Okay. We had some fun, right? At least I was making a fool of myself. I didn't have a stage to sing, you know. If I sing on stage and the audience will be empty, you know. So now you guys are forced in this space. You have to listen to my singing, right? All right. So now your turn. Okay, I have designated a question for you to do. Are you ready? How about number 17? Okay, your turn. You're gonna do the 3 parts. Okay, you're gonna do the 3 parts. Log base 2 of x plus log base 2 of x plus 2 equals to 3. Okay. And I would like to see you guys submit some work. Do you want to do some more? Let me give you a couple more questions. How about that? So you can choose between, and then you submit work, okay? 17. 20, 23. Okay. 20. For now. Twenty is common log x plus common log x minus 3 equals to 1. Okay. (21) log base 6 x plus log base 6 x minus 1 equals to 1. So your turn. Great. We got submissions. Very good. That's great. Let's see where submitted. Andy. Okay, got it. Thank you, Andy. All right. Could everybody see? Could everybody see clearly? on the screen. Oh, I haven't shared. Sorry.
I'm gonna redo it because I made a mistake.
Oh, you want to resubmit?
Yeah,
Okay, no problem.
I didn't put it in the original equation.
Oh, but that's okay.
I,
Any
I,
other changes?
I still got it right though, but I think.
Okay, so let's check. Okay. Thank you. Very good. Very, very good. Okay, so hold on. So let's check the steps, right? So when we set up to find the domain, okay, so your domain is x larger than -2, is that right?
Yes.
But how do you take care of log base 2x? Because according to you, x larger than -2, 0 is larger than -2. But if you plug in 0, the first one will be undefined. Do you see what I mean?
Yeah.
So something is missing from your domain finding. Yes?
Yeah.
So you also need and x is larger than 0. Combined domain is x larger than 0. You see that?
Yes.
Okay. So let's check the rest of your work. Okay. So you use the product rule. That's very good. And then you apply definition correctly. Very good. And then you rewrite it and make 0. Wonderful. Factor, solution, and -4 is outside the domain. Perfect. Okay. For x equals to 2, I would ask you to remove that part. Okay. And put equal sign here, equal sign there, and equal sign there. Got it?
Yeah. Thank you.
Very good job. Very good job. Okay. There's a minor mistake here, but you understand what I meant. Do you have any questions about that correction?
No.
Good. Anybody else would like to submit? Thank you, Andy. Very good job. Next person. You're working on it, right? You're working on it. Very good. Is it fun? Are you singing? You probably will sing better, right? You probably sing Raul. You know, my bad. I copied the 21 here, but I meant 23. I didn't copy 23, my bad. But that's okay, okay? We're gonna get to it, okay? Just one more question that we're gonna work on. Solving this equation. Nice. I hear another submission. Thank you, Bailey. Very nice. All right. Do you guys see? So to determine the domain, so he set up x is larger than 0 and large x larger than 3. Combine these two. Did you box x larger than 3? Is that, do you mean that's a domain, or you mean this latter one is domain?
I just went with x is greater than 0.
So you think the final domain is x larger than 0?
Yeah.
Well, what if x equals to 1? So what you have, you will set up as x is larger than 0 and x minus 3 is larger than 0, right? Then you solve it x larger than 0, and then you get x larger than 3. If you combine the above, the domain should be what? The domain should be x larger than 0, or the domain should be larger than 3. That's my question. If you chose greater than 0, then you're telling the reader 1 is in the domain, 1.5 in the domain, 2 is in the domain. But when you plug in 2 or 1 in the equation, one of them is not defined, right? So the domain, the combined domain actually should be x larger than 3. Because you want both are meaningful. You want both are always in the domain. Remember, this is a function. This is the function. Think of function. Okay, think of function. What do I mean by think of function? Right? What you have here is that you have a domain. Okay, so you have an input here. The input goes to what? The input is taken by what? Log x, right? And the log x minus 3. And we want the output to be 1. Okay? So both have to be guaranteed in the domain. You cannot say, oh, I have a log 2 here. Log 2 is okay, but log 2 minus 3 will not be okay. Log negative 1 is undefined, right? So the domain is going to be x larger than 3. Does that make sense to you guys? Okay, good. All right, so let's look at the next step, right? So he copied the question, product rule, no problem, and definition. Excellent. Perfect. Here, missing equal sign. I'm just basically showing you how I'm grading your work. Okay, when you turn in, you submit your work, and I look at on the screen, and I'm showing you how I grade your work. Okay, so you get these. That's good. And negative 2 is not in the domain. X larger than what? Over here, larger than 0 would not be right, right? It should be larger than 3, right? So that's how I check your work. I check your work line by line, left to right, top to bottom. So that's how I grade your work. I don't know how other professors grade your work. I assume probably similar. Okay, now checking the work. Start from left, like it. 5, common log 5, 5 minus 3, 10, product rule. Perfect. And then of course, x equals 5 is a solution, right? You just have to maybe summarize, right? You can say x equals to 5 is a solution to the equation. Okay, it's just nice. You treat that work you do, it's like writing an essay. You have a beginning, you have an end, you have your logic, you have your sequence of statements. Okay, if the sequence of statement must be if statement, then you give them if statement, right? And these are if a sequence of if statement. If then, 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 right? Then. And then you go here and left, right? Then you tell the reader the left is this guy, plug in, and is the same as, is the same as, is the same as, and is the same as, right? Therefore, x equals 5 is a solution. You're done. It's really like you know, we save a lot of words because we use mathematical symbols, and this is a great work. Okay, Billy did a great job. However, it seems that we have some difficulty with the domain domain determination. Okay, so that's something we need to be careful about. Okay, you need to understand. So I'm gonna close this down. I'm going to show you how to determine the domain once again, okay? So I want you to pay attention to this, okay? So did you write it down? This is my correction. Okay, this is my corrections and stuff. Thank you for sharing. So let's go back to that part. Okay, so to determine domain, so what are the thoughts that go into it? What are the thoughts that go into it? Right, I don't want you guys to have to memorize. No, you don't need to memorize. I want to show you what are the thoughts that going through it. X is larger than 3, okay? So why we determined eventually the domain is X larger than 3? First of all, the end is a very important word because that set up the entire logical relationship. The entire logical relationship of determine the domain. If we agree this is right, well, this is right. Why? Because it will guarantee that this is meaningful and this is meaningful. You will never have undefined case. Okay, so then we look at the number line, right? One is X larger than 0, and the other one would be larger than 3, right? How do we determine this logical? What is the, if we combine these two, what do we get? Right? If we combine these two, what do we get? This is true if both are true. Yes? Remember the truth table we learned before. A and B is true only when A and B are both true. Do you remember that? Okay, so you will treat this guy as A. This is a statement. This is a statement. This is not an if statement. Okay, X is greater than 0. This is required. And X is greater than 3. So to make this true, we have to make X larger than 0 and X larger than 3. When we combine these two, we're saying that this is a statement A and this is statement B. Okay, this is statement A. And this is another statement. Okay, statement A, and that's a statement B. Look at truth table, okay? And they're connected by and. They're connected by and. Okay, so when I was drawing these, when I was saying, when I was putting these symbols there, right? When I was putting these symbols there, larger than 0 means what? Larger than 0. From 0 to the right. These are the places that if you pick those numbers, it will make A true. Do you follow me? These are the input X, such that X larger than 0 is true. Okay? And these are the numbers larger than 3. These are the numbers of X that will make the statement B true. Yes? So these heart, okay, that's where Make A true. Make a statement A true. And the star, okay, make statement B true. Okay, when you want to make both A and B true, where can you make both A and B true? That's where you have just heart and a star, right? When you have heart here, without the star, that means it makes A true, it doesn't make the B true. Do you follow me? So you need to make A true and B true, because only when A and B is true, you get your mission accomplished. Makes sense? Now, what is the meaning of A and B? Remember the definition we have learned before? A and B, right? A and B is composed of entities, entities such that X is in A, that entity is in A, and X is in B. Okay, so I want you to reflect on truth table. Okay, so if X is in A, X is greater than 0, and X has to be in B. Both have to be true. So these hearts, okay, these hearts and the star are overlapping. They are from the same place, but these are not. These axes will only make the A statement true. It does not make the B statement true. So when B is false, A and B is false. Got it? When A is true and B is false, A and B is false. When A is false and B is true, A and B is false. Got it? So it is actually following that logic that we have determined the domain. Do you guys follow me? Do you guys understand? Logic. Okay? That's why our final answer after combining these two is X larger than 3. Okay? Because you can see X larger than 0 will include all of these numbers larger than 0, including 3, including numbers larger than 3. A lot of these numbers will not make a statement B true. Actually, in fact, all of these numbers will not make a statement B true. And they have to be out. They have to be out. Okay? Yes? All right. Let's look at chat. Should be X greater than 3. Yes, you're right, Mikhail. Okay, I got it. I got it. Very good. Okay. Do you guys hear the logic? I want you to make that connection. I want you to make that a connection to the logic. In case that you are confused, in case you're confused, you can always trace it back either to function or to logic. That's why I paid that's why I gave this word 1 point. I gave this word 1 point in this setting. Do you follow me? I gave this word 1 point. Okay. So far, so good. Okay. So A and B is true. Okay. So I'm going to just put this away. Excuse me. All right. And the rest of work, and Bailey did a great job. Okay, I think just on the domain part, I see some we need to address these issues, right? The logic. Okay, and he did the rest very well. So for those of you guys are ready to submit the other two solution to the other questions, and go ahead. All right, so how about 21 and 23? Yeah. The truth is that in mathematical expression, every word matters, especially those words and, or, therefore, because, and all of those words. And we actually don't have a lot of other vocabulary. In mathematics, there are not a whole lot of exciting vocabulary. Okay, your typical vocabulary would be because of this, then, because, if, then, because, and these are typical words. Okay, they're not a very rich in vocabulary, but they have to be logically connected. Okay, now we were very good. So let's see who has done the submission. Thank you, Mikhail. I got it. Mikhail. Okay, so let's look at Mikhail's work. He's working on number 21. Excellent. Upload it. I found if I download it, I can make the size larger or smaller. But anyway, we usually like to make it larger. Okay. Let me make just a little bit larger. All right. So we put the domain x larger than 0. Okay, so he has larger than 0 and greater than 0 here. The final domain is x larger than 1. That's correct. Okay, very good. And then he did the product rule and definition at the same time. No problem. Okay. And he solved the equation by factoring +3 and -2 minus x plus 2. If I were you, I would try to make those writings a little bit more clearer. Okay. But I can see it, but this 2 is not that clear. Okay. All right, but it's correct. It's correct. So try to make it clearer. Okay. Thank you. And left-hand side, log. So here we have a -2. -2 is outside domain. Is that what you're writing there? Outside domain. Okay. That's all right. You'll do better every time. I only see you guys will improve, right? And I'm here to tell you what to improve on, right? And you guys are not going to take it personal, yeah? You're not going to take it personal, okay? Just view me as your your school mom, right? And I sometimes just have to tell you things, and right? You guys about the same age as my children. So you're my children. Okay, so I tell you, hey, this needs to be better done, and this, you need to tidy your room here, you know, you need to put away these and put things back where it belongs. But anyway, I'm just doing that kind of thing, okay? Housekeeping. But anyway, equal, I would just like to see equal sign here. And here. Oh, that's perfect. Very good. Good job. Good job, right? We are almost running out of time. So anybody want to submit 23? I'm very pleased to see you guys work. Okay, I'm very pleased to see you guys work. Okay, so you guys got 21. Okay. If you don't have any submission for 21, 23, I'm going to go for it. Yeah, because I do want to complete all of these at the end of before the end of the class. 23 is actually, I put it here as this is from Professor Bateman. I don't know where he got it from. Maybe he invented this question. Okay. I found this question very interesting, and it's a good question. So I just stole it. Okay. And has he complained about it? No, not yet. Okay. Now, first of all, we need to know the difference between these two. Okay. So think out aloud. Okay. This expression means ln x times x. And the other expression means what? It means ln x multiply ln x. They are different. They are very different. Okay. So when we are to determine the domain, okay, we need to make sure that this x is larger than 0 and this x squared is larger than 0. So when we are to determine the domain, that we need to we're going to start with x squared is larger than 0. Okay. And x is larger than 0. Of course, combine these two, what will be the domain? What is the solution to x squared larger than 0? I just out of my curiosity, I want you to tell me that answer. Suppose you're not dealing with this end situation. What is the solution to this guy? Yeah. All real numbers. All real numbers include 0. Do you mean 0 is a solution too? Portland? Apparently not, right? All positive numbers? All positive numbers. But what if I give you x equals -1? Will that make it true as well? So the first answer is all real numbers. That's right. Okay. So this answer, A this is B, A, all real numbers, right? So you see, in each case, I have given you some counter examples, right? So let's look at the last one. All real numbers, X cannot be 0. This is correct. Okay, in other words, you can just simply write X is not 0. Okay, that would replace those words. Okay, so all real numbers except 0. Okay, however you say it. And the answer, Cortland gave there in the chat is correct. It's absolutely correct. Very good job. Okay, so what does this mean? The solution to this inequality or if statement is X, all the negative numbers and all the positive numbers, right? You follow me? So the answer is what? X is not equal to 0. Or another way to express it is what? X is less than 0 or X is larger than 0. You follow me? Now, so now look at the domain. So the solution to this guy is greater than, less than 0 or larger than 0. But and you need the other one too. So which one do you have a common, satisfy both? So what is the final domain? X has to be larger than 0, right? You follow me? Is that obvious? So now it becomes obvious, right? But you understand that the solution to this if statement is all real numbers except 0. 0 is that fateful number we often has to pay attention to specifically. Okay, now the domain is determined. What's next? Solve this equation. With that understanding, right, what does this equal to? This equals to 2 times ln x, right? Power rule, right? Power rule. Or you can use the product rule. You're going to get ln x plus ln x, right? Right, you're going to get ln x. If you use the product rule, you're going to get ln x, right? So you still end up with 2 times ln x, right? No difference. So now with that in mind, so on the left-hand side, we're going to get 2 times ln x equals to ln x squared. And then what? And then what? So we have ln x here, we have ln x here. Shall we introduce a intermediate variable as u? So what do we end up with? We end up with 2u equals to u squared. Quadratic. Quadratic. Ta-da! You see that? Quadratic. Quadratic. Don't we love quadratic? They just show up. They just show up. Yeah? Do we know everything about quadratic? Remember that module, notes I wrote down there? You need to know everything about quadratic. We need to know everything about quadratic. I hope I didn't leave out anything. I might have, left out something out there in that everything quadratic. I was boasted. That title was kind of boastful, isn't it? I hope I didn't leave anything out. Please let me know. Okay. All right. So what do we do to solve this equation? Could I cancel one of the u from both sides? Is that a very basic question? It is a very basic question. Could I cancel the u on both sides? We might go beyond the class a little bit. Okay, I try not. Can we cross out a u from both sides? Let me give you the answer. Absolutely not. Why not? Because we don't know if the u is 0 or not. U could be 0. Why? Because the range of ln x is all real numbers, including 0. So u could be 0. If u is 0, you cannot use principle number 4. If you cross them out, you're using principle number 4, right? Do you guys follow me? Principle number 4 says if A is the same as B, right? Then A times C is B times C, where C cannot be 0. Right? So when you cross out that U on both sides, what have you done? You have assumed C is not 0, but we don't know C is 0. When you cross out U could be 0. Please don't do that. You know, guess what? Someone made that mistake before. You cannot cross them out. So what can you do? Right? So we get U squared. This is what you should do. U squared minus 2U. Whenever you encounter these equations, whenever you think of crossing out, be aware of principle number 4. Remember, we talked about that, and we talked about the contradictions that we have proved at the beginning of the semester, right? So this is the safest way to do it. Okay, and you also find out if you do that, you can also miss a solution. Okay, and what you get U equals 0 or U minus 2 equals to 0. Okay, and in the end, what do we get? Not closer to the end. U equals to 2. Now it's time to bring back U equals to ln x. Okay, so that is ln x equals to 0 or what? Ln x equals to 2. So what are the solutions when ln x is equal to 0? What input for ln will cause the output equal 0? 1, right? ln 1 equals 0, right? Or think about those questions we have in log 15a at the beginning, right? X equals what? What does X equals to? Definition, right? Definition. What does definition tell you? What is it?
E squared.
That's right. E squared. Okay. Domain check. Both numbers are in domain. Right? What is our domain? X is larger than 0. Right? And then we're going to have to check the equations, right? Let's go check the equations. So this is the equation. Okay, this is the equation we'll check. Okay, so for x equals x equals to 1, the left-hand side, the right-hand side. Oops, sorry. The left-hand side and the right-hand side. right? So when that equals to 1 and that equals to 0. When that equals to 1, that equals to 0, right? So left equals to right. So you can say is a solution, right? Is a solution to the equation, right? Okay, so how about for x equals e squared? Yes, you still do the left and right, right? So left equals what? Ln x squared. Right. Okay. And the solution we're checking is e squared. Oops. Sorry. Right? And over here, this is e squared. What do we get? In this case, you do exponents first and then apply ln. So you're going to do ln e to the power 4. And that's, of course, is 4. In this case, you have to do the inside first and then square. So you do this inside first and you get a 2 squared. Do you follow me? There's a slight difference in order, even though we get the same answer, but don't multiply these two, okay? If you multiply these two, that would be wrong. But there's no way we can check it, but you need to understand the order of operation. So x equals to e squared is also a solution to the equation. So how many solutions do we have? 2. We have 2 solutions. Now think back about canceling the u's. Had you done that, you're missing half the solution. You see that? So not only you cannot use principle number 4, because principle number 4 has this gigantic requirement. It's huge. It's huge. Without, the entire mathematics will collapse. We're not exaggerating, right? Because without it, we're going to have 2 equals 1. If 2 equals 1, 1 equals 3, right? 1 equals 3, 1 is 5. The world is going to be upside down. Do you know how serious that mistake is? Very serious, very serious. Okay. Thank you for your patience. We went over some quite a bit, and I hope to see you guys on Monday. Well, I'm sure I'm going to see you guys on Monday. And you will have 2 quizzes. You're going to have a written quiz will be available this afternoon, and I will have another quiz for you. Will be most likely it's about concept checking and multiple choices. Okay, and very good job, you guys. And I especially appreciate and enjoy your feedback with me and in the class. It's tremendous. Okay, it just makes the learning so much more interesting, make the lecture much more interesting. Thank you so much, okay? Have a great weekend. And if you have any questions, please don't hesitate. Please don't hesitate. I mean every word I said. Please don't hesitate to reach out to me, okay? I want you guys to be successful, okay? I want you guys to do well, okay? From the bottom of my heart. Okay, and you're doing it. You're doing it. Okay, so see you on Monday, if not sooner.
All right, thank
you.
you.
Bye.